We said earlier that only quantities expressed in the same units should ever be compared. We also said that in science we typically carry out all calculations in SI units. Therefore, we need to learn to convert between different units for the same physical quantity, particularly to convert to SI units. Let's say that we know that the distance between the Hayward Hills and Concord campuses of Cal State East Bay is 34.1 miles, and that the distance between the Hayward Hills campus and our sister school, San Francisco State, is 54.3 kilometers. Which of the two distances is greater? To find out, we need to look up how 1 mile compares to 1 kilometer. The Google query miles to kilometers provides us with this information. 1 mile is 1.60934 kilometers. If 1 mile is 1.60934 kilometers, then the distance between the two Cal State East Bay campuses, 34.1 miles, is 34.1 times the length of a mile in kilometers, so 1.60934 kilometers, and that is 54.87863 kilometers. To get this result, we multiplied the number of miles by the length of 1 mile in kilometers. This distance is slightly larger than 54.3 kilometers, the distance from Hayward Hills to San Francisco State. Of course, you could also convert the distance in kilometers to miles. If there are 1.60934 kilometers to a mile, then there is 1 divided by 1.60934 miles to a kilometer, and that comes to 0.621371 miles to a kilometer. Therefore, 54.3 kilometers is 54.3 times the length of a kilometer in miles, 0.621371 miles, and that is 33.74046 miles. When converting between different units for a physical quantity, all you need to know is the conversion factor. You can easily find conversion factors for any pair of units for a given physical quantity online. For instance, the Google search pounds to kilograms will tell you that there are 0.453592 kilograms to a pound. Therefore, 5 pounds is 5 times the magnitude of a pound in kilograms, so times 0.453592 kilograms, and that is 2.26796 kilograms. On tests and quizzes, I will always provide conversion factors between different units for physical quantities that can be expressed in the base units of SI. However, what should you do if you need to convert units for a physical quantity for which derived units are used in SI? You can find such conversion factors using two things: the known conversion factors between units for physical quantities that can be measured in SI base units, and the relation of a physical quantity measured in derived units in SI to quantities that are measured in base units in SI. To clarify this statement, let's consider the following example. A snail's speed is 46.8 centimeters per hour. How can we convert the speed to meters per day? Well, we know that distance and time are both quantities that can be measured in SI base units, meters and seconds, respectively. We also know how speed, a quantity that is measured in derived units in SI, namely in meters per second, is related to distance traveled and time spent traveling. Speed is the distance divided by time. Then we can reason as follows. When we say that the snail's speed is 46.8 centimeters per hour, we mean that a snail travels a distance of 46.8 centimeters in 1 hour. What is the distance that it travels in a day then? We know the conversion factors between hours and days. A day is 24 hours. So, in a day, a snail will travel a distance that is 24 times greater than the distance it travels in an hour. 24 hours times 46.8 centimeters per hour comes to 1123.2 centimeters. Now, because 24 hours is the same as 1 day, we can rewrite this expression as 1 day times 46.8 centimeters per hour is 1123.2 centimeters. Or, if we divide both sides of the equation by 1 day, we will get 46.8 centimeters per hour on the left is the same as 1123.2 centimeters per day on the right. So we actually converted our speed to centimeters per day already. Notice that when we were multiplying values, we also kept track of units. For instance, in our first line, we wrote 24 hours times 46.8 centimeters per hour equals to 1123.2 centimeters. The hours in the first term cancelled out with the hour in the denominator of the second term, leaving us simply with centimeters. Now we have our speed of the snail in centimeters per day, but we want it in meters per day. So how do we do this conversion? First, we realize that a speed of 1123.2 centimeters per day means that the snail moves 1123.2 centimeters in 1 day. How many meters is that? Well, there are 100 centimeters to a meter, so 1 centimeter is 1/100th of a meter. 1 centimeter is 1/100th of a meter, and 1123.2 centimeters is 1123.2 times the length of a centimeter in meters, and that is 0.01 meter. And when we do the multiplication, we get 11.232 meters. So our snail travels 11.232 meters in a day, meaning that its speed is, by definition of speed, 11.232 meters per day. You can see that we did the conversion from centimeters per hour to meters per day in 2 steps. First, we converted to centimeters per day. The numerator of the unit hasn't changed, but the denominator has. Then we converted centimeters per day to meters per day. The denominator of the unit hasn't changed, but the numerator has. We used the definition of speed, distance traveled per unit of time, first calculated the distance in centimeters traveled in a day, based on our knowledge of the distance in centimeters traveled in an hour, and then we converted the distance in centimeters traveled in a day to the distance in meters traveled in a day. We could have also switched the order of the last 2 steps. It wouldn't have made any difference to the final answer. Try it and see for yourself. Although it is entirely possible to find conversion factors between any 2 units that are used for the same physical quantity online or in a table, being able to reason out conversion factors as we have done here based on relationships between physical quantities is a useful skill nonetheless.